Um, yes, you can plug this in the calculator. That's what we should all do. But here's what I would like to do. Can I do this? You can say there is no need for that. I will agree. But can I do it? Right? It's one of our formulas. A squared minus b squared, which is a minus b times a plus b. So if I have no calculator, I may consider this and not square these two. So 28 minus 15 is 3, and 28 plus 15 is 43. 3 times 43 is 129. Unless I did something else. Oh, yes. Oh, no. Yes, you're right. 13 times 43. So what is that? So 559? Yeah. Very good. Of course, you don't have to do that. But if you don't have a calculator, you can do that. It's easier. Okay, so then we take the square root. I should write plus or minus because I remember it's a quadratic. You should have two solutions. However, since x is a distance, and if you have the approximate in feet, I will put it in. Any questions on this? Any questions on this? Do we have the number? How much? How much? Is it? 23.6. Very good. Perfect. Okay, I would like for a second, we have one more section to go through, but I would like to go back to our handout because we stopped at page 4. We only read a little bit on page 5. And when we go through these problems, then I will come back to the last page, which is complex numbers. Okay, so radical expressions, we are just reviewing this. We know this. There are no negative exponents, so they are fully simplified if there are no negative exponents in the final answer. 2, the exponents under the radicals are numbers smaller than the index. We know that. We just had a few examples today. There are no radicals in the denominators because we need to rationalize the denominator. Okay. I think we worked on this problem, but it's a good exercise to do it right now. So we can complete this handout. We'll do it again. We'll have to do it again when we review. So we have x to 1/4 divided by x to 2/3. How will I simplify this? Copy the base, and what happens with the exponents? Yes, 1/4 minus 2/3. Excellent. Now, did you do this problem before? I don't remember. What am I trying to do next? Right, which is? Very good. So I need adjustments for the tops. What is the adjustment for this one that has 4 in the denominator? And this one that has 3 in the denominator? 4. So then the numerator is?
3 minus 8.
Yes, 3 minus 8. So this is -5. So x to -5/12. So no negative exponents in the final answer. What do I do? Very good. Excellent. 1/x to 5/12. Okay, but this is what type of expression that has a fractional exponent? Radical. Very good. 1/, which radical is this? Yes. X to which power? Very good. And now I know I want to rationalize it because I want to get just x in the denominator and nothing else. What do I need to do in order to rationalize this radical? Multiply top and bottom by? Yes. I agree with that. It has to be the same index. X to the 7th. Exactly what I'm missing from 5 to 12. Very good. X to the 7th, X to the 7th, and that's it. Don't be tempted to simplify. You cannot simplify or do anything else here. This is it. Okay, adding and subtracting radical expressions. Like radicals are those radicals with the same index, same variables raised to the same powers, and variables are placed in the same position in the radical expression, outside or inside. So only like radicals can be added and subtracted. I think we worked on these problems together already. Okay, very good. So now at the bottom of page 5, distance and midpoint formulas. This is the distance. Remember, you cannot simplify it. How come I cannot simplify this? Because the radicand, or the quantity under the square root, is a sum of terms. I cannot break it if it's a sum or a difference. What is this? The midpoint formula. So we worked on a problem already. So page 6. Principle of powers and solving radical equations. We raised both sides to power n. That's the principle of powers. However, this is not a basic principle of equations, like adding numbers or terms to both sides of an equation or multiplying both sides by a non-zero number, to name a couple. Therefore, there is potential risk of obtaining extraneous solutions. How do I correct that? Check the answers. So check. Back to the original problem. So here is how I correct it. Extraneous solutions are solutions that do not work in the original equation. When solving radical equations by the principle of powers, we must check all prospect solutions where? Back in the original problem. Back in the original equation or problem. When we review, we're going to work on these. Okay, the square root property. When I have x squared equals k and I take the square root from both sides, what do I write? Not the intermediate step. What do I go directly to writing? Exactly. That's what I have, plus or minus the square root of k. When we review, we're going to work on these two problems. Okay? So this is from the last section. So allow me to talk about this. So 10.7, complex numbers. Yes, Becky? It's the radical equations. Okay. So the question I have for you here is, don't we have enough numbers? From negative infinity to positive infinity, don't we have enough numbers? No. Here's what the problem is. What if I want to solve this equation? I cannot factor. X squared plus 4 is not factorable. It's the sum of squares, not the difference of squares. So what am I thinking of doing is moving 4 to the other side. And then you will say you have to apply the principle of square root. This one here, the square root property. You apply the square root property. Okay, and then I get stuck. Why do I get stuck? Yes, the square root of negative 4, I know it's not a real number. So how do I proceed from here? I will have to break up the square root of negative 4 into two pieces. The square root of negative 1 multiplied by the square root of 4. The square root of negative 1 is called the imaginary unit. The imaginary unit. Oops. The imaginary unit. The notation is I. How much is the square root of 4? That I know. 2. So then the answer is 2I. So I can come back and finish up solving the equation as the square root of x squared equals the square root of negative 4. I just copy the equation. And then I have x equals, what am I missing here? I have to write 2I, but before that, what do I have to? Plus or minus. And you will say, where is this used? It doesn't even exist. It's an imaginary number, also called complex. So imaginary number or complex number is the same thing. Where will I ever use this? It doesn't exist. You can graph this on the Cartesian system. It has a lot of applications in physics and many other engineering and so on and so forth. So yes, I cannot graph it on the Cartesian system, but there are other systems in which we can graph it. Okay, so that's the reason why we had, not me, very smart people invented complex numbers, because we could not solve this equation using real numbers. This equation has positive plus positive equals 0. There is no such thing. A positive number plus a positive number can never be 0 in real numbers. So that's the reason why they invented imaginary unit and the complex numbers. So here's the general form of a complex number. A plus B times I. A is the real part. This is the imaginary part. So now if you want to know where are complex numbers in reference to real numbers, here is what happens. These are complex, and these are real. In other words, I'm saying to you, any real number can be written as a complex number. So how will I write 10 as a complex number? 10 plus 0I. How will I write negative 7? Oh, negative 7 plus 0I. So complex numbers are bigger than real numbers. Now, how do I add, subtract, multiply, and divide complex numbers? I know I have 5 minutes left, so we'll stop. We don't have to finish complex numbers today. We need 10 more minutes on Thursday. Okay, so give me 2 complex numbers so we can add them. In other words, you can give me any number in here and any number in here, positive or negative. You don't have to give me an A, but if you don't give me a B and B is 0, then it's only a real number, not an imaginary or complex number. So give me 2 complex numbers that you would like. Say it again.
3 plus 2i.
3 plus 2i, and let's use some negatives too. Let's say 4 minus 7i, or sorry, very good. So how do I add these? Very simple. Just combine like terms. 3 plus 4 is 7, and 2i minus 7i, negative 5i. Done. We just combine like terms. Let's use the same to subtract. So let's say I have 3 plus 2i minus 4 minus 7i. What will be the first step here? I have to remove parentheses, right? So I will write 3 plus 2i minus 4 plus 7i. And of course, I will combine like terms. So I have negative 1 and then plus 9i. Yes, Becky? We copied the same. We copied the same complex numbers, but we showed an example with addition. Now I want to show an example with subtraction. And then we're going to multiply them. So here's a question for you. How much is I one more time? We've never seen this before because there is no real number that replaces the square root of -1. So that's why it's the imaginary unit. Now let's say we square both sides. How much is I squared? Right. We have never seen this before because a positive number, anything that is a real number squared is positive and this is negative. There is no such thing. So all I know is that that I equals the square root of -1, and I know that I squared equals -1. And let's just multiply these two. 3 plus 2i, and then 4 minus 7i. And then I'll stop, I promise. So we want to multiply these two complex numbers. Of course, we have to use FOIL, unless they are the same, but they're not the same, so I can't use a formula here. I have to use FOIL. 3 times 4, 12. 3 times -7i, -21i. 2i times 4. And positive 2 times -7, -14, and I times I is I squared. But I know what I squared has to be replaced by. I just discussed that, right? We just discussed this, that this is -1. So -1 times -14, how much is that? 14. How much is 14 plus 12? 26. And how much is -21i plus 8i? That's how we multiply complex numbers.